Okay, so yesterday we learned how to actually make these perfect square trinomials by adding a certain number and then factoring it into its perfect factors that are both the same. Here are the actual steps that are going to allow us to solve an equation that's in standard form using this method of making perfect squares. The first thing we need to do is divide everything by a. So if it's in the form a squared plus bx plus c equals 0, here, we'll go through these steps in an actual problem. So number one, the first step would be to recognize what a is and then divide everything by the a value. But number one doesn't have an a value, so we don't need to do that. The second step is going to be to bring the c value to the other side. So we see that 4 is the c value, so we want that on the other side because we don't need that on the left side. On the left side we have x squared plus 6x. Now on the left side I do want to create a perfect square trinomial. Now that the negative 4 is on the other side, I want to find the number that goes here that will allow me to factor this into a perfect square trinomial. But if I add a number on this side, I have to add that same number on the other side. So when the negative 4 goes to the other side, I do need to add a blank here. Now, from yesterday, we should know that the left side will factor into half of 6, which is 3. So it would be x plus 3 squared. The left side will factor into x plus 3 squared, which means that the number that goes here is just 3 times 3. It's 9. Which means the number that go here is 9 as well. So when I put 9 on this side, the negative 4 and the 9 will make 5. Alright, this is what I want. I'm now going to solve this. Alright, so this is the form that I want it in. Now that I have it in this form, I can solve this. So after I've completed the square, so I move the c, move c, complete square, and this part should look familiar. There's actually a square here. I'm now going to start solving this by square rooting both sides. So I'm going to square root this side and square root this side. Don't forget the plus or minus. This is actually solving by square root method. The reason I want to do this is because this square and this square root will cancel each other out, and I'll be left with x plus 3 on the left side. On the right side, I just have plus or minus the square root of 5. The square root of 5 cannot be simplified. There's no factors that I can bring to the outside, so we're just going to leave it as the square root of 5. I now want to get this x by itself, which means subtracting this 3 to the other side. Now I have my solutions. My right side becomes negative 3 plus or minus the square root of 5. This represents two solutions, and we don't want decimal points, so we're just going to leave it the way it is. The first solution is negative 3 plus the square root of 5. The second solution is negative 3 minus the square root of 5. And those would be our two solutions to the original problem. And we did this by completing the square, by making a perfect square trinomial. After the square root, you always add or subtract. That's always the next step. So it's really a short process. You move the c, you complete the square, you take a square root, and then you add or subtract. After those 4 steps, you will have your x by itself. There's nothing left to do. Now sometimes there is a first step before you move the c, and we're going to see that in the next problem. Because the next problem is 3x squared minus 6x plus 9. Now you'll notice that in this problem the a value is 3. So before we can move the c, we have to get rid of that. So we divide everything in the equation by that a value, because you can't complete the square with that there. So this becomes x squared minus 2x plus 3 equals 0. Next, I move the c to the other side. So I have x squared minus 2x. I'm going to leave some room to complete the square. On the other side, I have negative 3. I'm going to leave some room because I'm going to be adding something to both sides to complete the square. I only need it on the left side to complete the square. Now the left side should factor into x and then half of negative 2, so minus 1, x minus 1 squared. In order for that to happen, here I would have to have negative 1 times negative 1, so I'd have to have 1 here, which means I also have to have 1 over here, which means the right side is negative 3 plus 1, it's negative 2. Alright, this is what I want. This is what I want because I can solve this. So let's add those steps again. The first step was divide by a. The second step was move the c. The third step was complete the square. Now the fourth step is coming next, and that is to square root. Okay, you see I square root here and I square root here. Well, don't forget the plus or minus. Well, the square root and the square will cancel each other out, and I'll be left with x minus 1. On the right side, I have plus or minus, well, this is negative, so we need the I. It's I square root 2. Remember, because a negative square root means that we take out an I to simplify it. After we square root, we add or subtract. In this case, it's addition, because we have the 1. And now we have our solution. It's 1 plus minus I square root 2. And remember, this represents two solutions. 1 plus I square root 2 and 1 minus I square root 2. And those are our two solutions to the original problem, and we found this by completing the square. So it's at most a 5-step process, but you do need to find out how to complete the square, and you find the factor by taking half of the b term, and then you find the actual number to complete it by multiplying it by itself or squaring it. So let's take a look at number 3. So there is no a value here to divide by, so we don't need to do that. So we'll first start by moving the 25 to the other side. So on the left side we have x squared minus 6x. Let's leave some space to complete the square. On the right side we have negative 25. We'll also leave some space because the same number is going to get added. We know that the left side should become a perfect square. It should be x and then half of negative 6, so negative 3. Which means that this number here should be negative 3 times negative 3, which is 9. And if I'm adding 9 here, I also have to add it here. So the right side becomes negative 25 plus 9, which is negative 16. This is what I want. I can solve it from this point. Now that I have it in this form, I can solve this. Alright, so I've got it in this form. I can now solve it. The first step to solving it will be to take the square roots. Don't forget the plus or minus. So the left side, this and this cancel, so we got x minus 3. On the right side we have plus or minus the square root of negative 16. Well, the square root of 16 is 4. And since it's negative, it's 4i. So we'll add 3, and this becomes 3 plus minus 4i. So our solutions here are complex numbers. We have 3 plus 4i, and we have 3 minus 4i. Those are our two solutions. Okay, so there's only 2 problems for this homework tonight. We got page 53, number 24, and then page 54, number 23.